Excellent. Right. Well, thank you all for coming along. My name is Simon Bennett, and this is a workshop on scripting OSAP. Before I get started, I would like to get a vague idea of who's here. So do you have any developers here? Any security people? Only 50-50, maybe more security. Anyone else want to admit to anything?
Architecture.
Okay, cool. Right, so this is actually the first time I've done this workshop, and if the recording all goes okay, it'll be the last time as well, because I'll just point people at the recording. I do have a plan. I expect this to go out of the water pretty quickly. The main thing for me is for you to get as much out of this as possible. So this is just kind of vague plan. I'll run through it and then check it's going to, meet with what you want, but we'll see how things go. You're going to have a chance to write scripts, and if you want more time or less time, we'll just kind of adjust it as we go along. So the first session, I'm going to give an introduction to scripting, why we have it, what it can do. Then I'll talk about the standard scripting language we support. Then I'll get on to particular types of scripts. So the proxy and HTTP sender scripts and the passive and active scan rules. For each different type of script, I kind of do them in pairs because they're related, and I'll explain what they do, why they're there, show you the templates, maybe do some examples, and then we'll have a play around with them. And it's very much you can do whatever you like. You can try have a go at every type of script, or you can just focus on one particular one if you want. It's all up to you. Session 2 is going to be a little bit different because we're going to go on to Zest. Has anyone actually tried using Zest here? Yep. So one person, which is good. This doesn't surprise me. Zest is very powerful, but it's really badly documented, even worse than most of the scripting stuff as well. That's why this workshop is hopefully going to be a major part of our documentation. Then I'll talk about standalone and targeted scripts, and they will be for Zest and for all the other languages as well. Then from 4 p.m. roughly, the plan is to talk about using scripts and automation, and how to quickly go through how to add scripting support in add-ons. And then talk about authentication scripts, which could be interesting, and you have a chance to write those or any other scripts. And the last session is very much free for all. You can wander off if you like, if you want to stick around and carry on scripts, or we might carry on if doing some of the stuff we haven't had a chance to go through it by then. We ask questions or whatever you want. So that's the plan. Does that sound reasonable? Is that the kind of thing people are expecting?
Yep. Yes.
Excellent. Right, I'll get started. First thing to say is we have a competition. So one thing we're always on the lookout is for more examples of scripts. So what I'd love you to do is submit pull requests to the community scripts repo. That's under ZA Proxy on GitHub. And it can be pretty much for anything. And anything that's useful, and by useful, if you think you would have found it useful at the start of this workshop, then please submit it. And if you do submit anything useful, you'll get a Zap contributor sticker, which I've hidden back here. And if you give loads of scripts, or just one particularly amazing script, then I'll send you a Zap t-shirt later on. And there's no limit to Zap t-shirts, so if you all do amazingly well, then I have to send out loads of Zap t-shirts. That offer is only valid for this workshop, hasten to add. Although if you do contribute to Zap, then you see me grab a contributor sticker anyway. So, first introduction is, why do we actually need scripts? Zap is an open source project. You can download the source, you can change anything you like, so why do we actually need scripting as well? One of the problems is Zap is quite a large and complex code base, so it takes quite a while to understand how it works and where you need to make changes. And even if you do, to actually make the changes, particularly if it's an add-on, you then have to go and redeploy them, and these things take time. Even for me, you have to have the development environment with you, and if you're a pen tester on site, you might not have that. And even if you've got it all set up, it's still quite a long process. Scripts change things instantly. As soon as you've written them, as soon as you change them, you're affecting Zap. You're effectively rewriting Zap on the fly. So they're very quick to write and test. You can quickly iterate through, as you'll see later. You have, unlike commercial tools, we can give you full access to everything. So you have access to all the Zap classes, all the data structures, all the internals. So scripts should be as powerful as the core language. There shouldn't be anything you won't be able to do. Whether it's documented well enough is another matter. And you don't need a separate development environment. You don't need Eclipse or anything like that. There are some disadvantages. Documentation, as I mentioned, could definitely be better. When I wrote these slides, we didn't have autocomplete. We do now have a basic form of autocomplete. which does make things a lot better. It's not perfect, it's not full autocomplete, but it's, I think, good enough, and you'll see later. The other thing is there's no sandbox. So basically scripts, this is an advantage, they have the same power as the Java code, but they have the same power as the Java code. They can do pretty much anything that your user can do, so do not run scripts that you do not trust. I'm okay with that. So, the scripting language supported. We have a range of them. JavaScript, so this one's actually built in. And we have two optional ones, Python and Ruby, actually JPython and JRuby, but they are optional add-ons, so I'll show you how to download those in a moment. Then we have Zest, and Zest is quite a different beast from the other ones. It is built in, and it's more like a macro language. I call it a macro language on steroids. The way we implement all of these is there's a Java standard called JSR 223, and it's the way of integrating scripting languages with Java, and that's the mechanism we use for integrating scripting languages. So if there are any other, and there's hundreds of ones that conform to 223, so if you want another scripting language and it conforms to that, it's relatively straightforward to integrate with Zap. We don't have any plans to do any more, but people have been requesting it, but if you send us a pull request for another language, that'd be great. So we don't have a problem with that. There is actually one other language that is supported. There's a Bean Shell add-on. That's kind of quite different. It's preceded all of these. It doesn't have the same templating mechanism. It doesn't plug in the same way. It's much more just a console where you can integrate with, much more like standalone scripts. I'll explain those later. So I'm not going to cover that. I think it's kind of a bit out of date, really. So what we do is we actually have a load of different scripting types. And the types are very specific, so they do specific things. We have standalone scripts, and these are the easiest to understand. You run them. They stand alone, they do whatever you tell them to. Then have targeted scripts, and targeted scripts are kind of similar, except you invoke them, you say what you want them to run against. So you typically right-click on something in the sites tree or the history tree, and then when the script is invoked, it'll run against the URLs you specify. But other than that, they're kind of similar to standalone. Then we have proxy scripts. These change proxied requests on the fly. So as you're proxying through Zap, you can change the requests and responses before they get to the browser after they leave the browser. We also have HTTP sender scripts. These are really a kind of superset of proxy scripts. Proxy scripts only affect the requests from the browser, whereas Zap actually initiates loads of requests. So we've got the Active Scanner, the Spider, a whole load of other tools. And if you want to change any of those, you need to use the HTTP sender scripts. They also apply to proxy requests as well. So if you want to, you can just ignore proxy scripts and just use HTTP sender ones. We kind of implemented proxy ones first, then realized we needed something a bit more flexible. So those two are very closely related, which is why I'll go through them together. Then have passive scan rules. So as hopefully most of you know, Zap performs passive scanning by default. You can't really turn it off. And it does that in a background thread. So all of the built-in rules in Zap are written in Java, but you can add your own passive scan rules written in any of the scripting languages. Passive scan rules can't change anything. They just look at requests and responses. And then with the active scan rules, and these the nasty ones, these are the ones that perform the attacks. And again, you can implement these in any of the scripting languages. But this is when you just say, right, I want to attack this particular node. That's when you can start sending all your bad payloads. Then we have authentication scripts, and this allows you to automatically authenticate to a particular site you're testing. This is really great if you actually want to test different roles, different users. And we have script input vectors. So does anyone know what input vectors are? So with Zap, we have this concept. I'll actually show you quickly. So if we go to, if you want to attack something, we have some advanced options, and one of the things is the input vectors, and these define what Zap actually attacks. So you can see we've got things like the URL query string, post data, the URL path, form data, JSON, XML, and one thing down here is script input vectors. So Zap understands the format of various things, but doesn't understand the format of everything. The attack rules are independent of format. They just know, here's something I want to attack, and they don't need to understand the format behind it. Input vectors tell the rules how these things, how to actually extract the things you actually want to attack. and script input vectors allow you to define those yourself rather than rely on the built-in ones. And so those are all actually built in. Then we have a load which are added by add-ons because not only are the script languages pluggable, but the script types are pluggable as well. We have the fuzzer has quite a few, so we actually have some where you can manipulate the HTTP messages before and after they're fuzzed. And the same with WebSockets as well. So when you're fuzzing WebSockets, you can manipulate those before and after they're fuzzed. You can generate payloads as well. So with a fuzzer, typically you'll be using fuzzing attacks defining files, but you can actually define them in scripts as well. So you can come up with all sorts of fun things there. And we have payload processors, and we've got a load of built-in ones, but these actually manipulate the payload. So if you actually need to encode something in some way for the application you're working with, we've got built-in ones, but you can also define them by scripts as well. And finally, we have sequence scripts, and they're a bit unusual because all the other types you can use pretty much all of the scripting languages. Sequence types have to be defined in Zest, and that's because what you're actually doing is you're telling Zap a particular sequence of requests. So you're going through a wizard, and this will allow you to actually attack the last page in a wizard rather than just the first one. And typically, dynamic tools have a problem with that because they never get all the way through. So this allows you to define sequences to attack all the way along. That is an alpha rule, so it works in some cases, but maybe not all. So I'm going to start with describing the standard scripting languages, and these are JavaScript, Python, and Ruby. And I kind of think they're all roughly equivalent. They have the same kind of functionality. They all have good Java integration. There are some subtle differences. With JavaScript, with Java 7, there's the Rhino engine, and Java 8, there's a Nashorn engine. There are some differences between those, which can cause problems. And there's actually, so with Zap 260, the one which is current at the moment, you can use Java 7 or 8. With the next version, we're dropping support from Java 7, so I suggest you move over to Java 8 sooner rather than later. But if you have any Rhino scripts you want to run in Nashorn, there's this magic command which we'll be using later. We can load a compatibility library, and then it will seem to work by magic. With Nashorn, you can actually load scripts from files, which is very useful. And with Python, you can define a path from picking up Python modules. We don't have that for Ruby just because nobody's added it yet. It may well be possible, but someone gave us a pull request for that, which was great. So I've got some useful links here. I'm not expecting you to write those down. The slides will be online later. So just for future reference, we have a Google group just for scripts. We've got one for general developer ones as well. We have a community scripts repo, which we'll be making use of later, and there's Java docs as well, which are always helpful. So let's actually get started. So I'm hoping most of you have got Zap installed. So what I'd like to do is fire up Zap. And the next thing, very importantly, is check for updates. So if you actually go to Zap, there's a button here which is Manage Add-ons, and you can check for updates there. And as you'll see, I'm completely up to date, and nothing there is, so I've got no option to update all. If there's anything for update, please do so. The other thing is install both the community scripts and the optional Python and Ruby scripts if you want to use those. What you can do is, if you type in a filter script, now I've got them all installed. If you go to the marketplace and do the same thing, and anything comes up, obviously I've got them installed so they're not there, but if you've got them, definitely install the community scripts, and if you want to use Python or Ruby, install those, but you're fine with just a JavaScript as well.